Strengthening of solid beam with fiber-reinforced polymers. Wood is one of the oldest known materials of construction, and it is the only naturally renewable building material. For many centuries, wood has been a natural material of construction for homes and other buildings, for bridges and waterfront structures, for poles and pole frame, for electric and telephone lines, and many other uses. Modern technology has increased the durability of wood, spurred a host of new wood products such as plywood, particle board, and other panel products, largely removed the limitations of size and from through the glue laminating process, and developed improved fastness with greater load carrying capacity. Wood material can be destroyed over time due to different environmental factors, for example, fungus and insects, rainwater. When the studies on the behavior of beams against the bending test are examined, it is known that fracture occurs on the bottom surface of the materials. Fiber-reinforced polymers are a scientific fact that reveals that fiber-reinforced polymers should be preferred in the solution of the problem, as they can be applied without damaging the wood's appearance as well as their properties such as lightness, corrosion, and flexibility. In this study, ash beams were practically reinforced in a U shape from the other part of the beam with basalt-based polymer fabric used for reinforcement purposes in the market. The beams were subjected to bending test in a universal test device and load displacement graphs. Bending strength and models of elasticity were obtained. Basalt fabric's technical properties. After the priming process, the wrapping process is carried out with the adhesive. Fiber polymer fabrics are placed on the surface by stretching in the direction of the fibers by applying a layer of adhesive, and in order to absorb the adhesive into the fabric, air gaps are removed by pressing in the direction of the fibers with a roller. Then, the second layer of adhesive is applied to the fibrous polymers fabric surface with a roller, and the fibrous polymers is laminated between two layers of adhesive. The wrapped beams were kept for 1 week before being subject to the bending test. In the bending test, the loading speed was set at 6 mm/minute constant speed, and the experiments were carried out. The span of the support points was taken as 300 mm in the experiment. The 3-point bending test experimental setup image is given in figure. Load displacement graphs and flexural strength models of elasticity obtained in the study are given in figure. It was determined that the load-carrying capacity of the basalt-based fiber-reinforced polymers reinforced sample increased by 40% compared to the reference sample. It was determined that the displacement amount of the reinforced beam increased by 3.32% compared to the reference beams. It has been determined that the beams reinforced with basalt-based fiber-reinforced polymers fabric have flexural strength and a modulus of elasticity. It was determined that the reference beams had flexural strength and the modulus of elasticity. It was determined that flexural strength value of reinforced beam increased by 18% and the elasticity modulus increased by 25% compared to the reference beam. Thank you for your attention.